A Brumby is a free-roaming wild horse found in large numbers in parts of Australia. Don't know why they couldn't have had a model horse picture in the last question, but anyway. The culling of Brumbies was banned in the year 2000. At this time, the estimated population of Brumbies in the, I'm not even going to attempt the name of that, national park was 1,600. Scientists have modelled the population, P of T, of Brumbies in that national park, T years since the ban, using this formula. P of T is 18,000 over 10.25 e to the negative 0.15 t plus 1. Use the model to determine how long it will take the Brumbies to increase to a number that is triple the number when the ban came into effect. So the ban came into effect, it was 1,600, triple that is 4,800, and you can see I've solved that on the calculator over here. I've just put solve 4,800 equals our formula, and I've got 8.77. So T is 8.77 years. From this model, determine the estimated long-run number of Brumbies in the national park. So if we just tend T to infinity, this term will tend to 0 because it's e to the negative 0.15 t. That leaves us with 18,000 divided by 1, and therefore it will be 18,000 Brumbies. You might want to put something, since it's 2 marks here, about the fact that that term is going to go to 0. It can be shown that the growth rate of the population of Brumbies can be expressed as dp dt is 1 over r p k minus p. Determine the values of the constants r and k. Well, we can straight away write down that the k is 18,000 because it's always just the carrying capacity when it's in there. So that's straight away. Now, from the formula sheet, we get dp dt is rp k minus p if and only if p is equal to k p naught over p naught plus k minus p naught e to the negative rkt. Well, in hours, it is 1 over r there, and that's just going to make that 1 over r there. So 1 over rk is going to be equal to, looking back at our formula, 0.15. And rearranging that, r is then going to be equal to k divided by 0.15. And that is 18,000 divided by 0.15, which is 120,000. And then we want to determine the greatest growth rate of the population of Brumbies. Well, these curves are always shaped like this, and they have a point of inflection there that's exactly halfway up. So this is going to happen when p is equal to 9,000, essentially. So dp dt is going to be 1 over 120,000 and then times 9,000 and then times 18,000, take away 9,000, which is also 9,000. So essentially that is going to be 9,000 squared over 120,000, and we can calculate that. And that is, I think it's 675. I'm just going to check that. And indeed that is correct.